when it comes to quadratic equations that have what are called a double root, I end up having some people that think that I misled them or that I lied to them about what a quadratic is and what its solutions are like. But let me go ahead and explain why that's not true. So if I look at my quadratic equation, I can set it equal to 0. So I could, if I wanted to, take all of that stuff and move it over, but I'm not going to, because I like to keep my life a little bit simpler, keep the x squared term positive. So I'm going to move him over, the negative 4x squared. So when I set it equal to 0, I get 4x squared minus 12x plus 9 equals 0. There's my standard form. Now, when I go to solve this, let's suppose that I'm not going to try factoring. I just want to go right to quadratic formula. Maybe I could factor him, maybe I couldn't. Maybe I don't feel like looking for the numbers. But whatever the case, I just want to solve him with quadratic formula. So once he's set equal to 0, there's a, b, and c. So I get x equals opposite b, 12 plus or minus the square root of b squared. I always square him as I go. It becomes positive 144 minus 4 times a, which is 4, times c, which is 9, all over 2 times 4. And something a little bit different is going to happen here with the number underneath the square root, what I call the discriminant. When I put that on the calculator or I figure it all out, I'm going to get x equals 12 plus or minus the square root of 0 all over 8, which is fine. 0 is a number. We can deal with 0 like we would any other number. And it's actually pretty nice because I know that the square root of 0, if I simplify it, I get 12 plus or minus 0 over 8. And I know in my head then when I add 0 or subtract 0, it doesn't make any sort of difference whatsoever. So I just get x equals 12 over 8. Or if I simplify, x is 3/2. And this is where people get a little anxious because I make a big deal out of the fact that every quadratic ever has 2 solutions. So where are my 2 solutions here to this quadratic? Well, my 2 solutions are still right there. I still have, if I think about it, 12 plus 0 over 8 and 12 minus 0 over 8. They just happen to both be 3/2 and 3/2 whenever I simplify them. So if I come back over here, I have 2 answers. They just happen to be the same number. So I only write it once. So x equals 3/2. And this is what we call a double root. The same answer twice for my quadratic. So let's look at the same example. Since I got, let me go back one slide quick. Since I got a rational answer, no square roots left, I know in the back of my head that I could have factored this. So let me go on to the same example. Now I'm ready to go. And I want to do this with factoring to show you where this double root comes from with factoring. So I know that if I set this equal to 0, I'm still going to get 4x squared minus 12x plus 9. And solving by factoring, remember you set equal to 0, then you factor. In this case, I can factor with a is not equal to 1. Find 2 numbers that multiply to a times c, which is 36, and add up to the middle, which is negative 12. I'm just going to give you the factored form in this case. I'm not going to go through the whole a is not equal to 1 process. This becomes 2x minus 3 times 2x minus 3 equals 0. You can start to see where I'm going to get the same solution because I have the same binomial times itself, or binomial squared. So I use the ZPP, the zero product property, which allows me to split this up and write 2 equations. 2x minus 3 is 0, and the same one, 2x minus 3 is 0. So I solve each linear equation and get x equals 3/2 and x equals 3/2. Those are my 2 solutions. I could circle just one of them, or I could box both of them in, or I could just write it once and write double root. But the fact is, I get the same solution twice, which is this whole idea of what a double root is. So with factoring, I get right here the same binomial, which obviously is going to give me the same answer. And when I go back to my quadratic equation, the key sign that I'm going to get a double root is that square root of 0 right there. So a double root is one answer who happens to be the same number that is a solution twice to my quadratic.